Okay, so today we're going to start chapter 3. We're going to cover section 1. Now, for some of you, you might have covered this in your pre-algebra course, but then again, for some of you, it may be new information. So the first thing we're going to talk about are parallel and skew lines. So parallel lines are going to be coplanar lines that do not intersect. So they're two lines that run side by side and they will never cross. Skew lines, by definition, are non-coplanar lines. They're neither parallel nor are they intersecting. So they're not in the same plane. So I'm going to show you examples of this with my tissue box and in relation to the classroom. So next we're going to talk about parallel planes. So those were parallel lines. Parallel planes are going to be planes that do not intersect. So if you talk about, again, the classroom, parallel planes could be the ceiling and the floor. So for example, in the figure here, I could refer to the top of this figure as a plane and the bottom. So this would be an example of two parallel planes. Remember, to name a plane, you need at least 3 letters. So I could say that plane ABH, and then the symbol for parallel are 2 straight lines, is parallel to plane CEF. Now, it doesn't matter what letters you choose to name the plane. If you wanted to name all 4, like for example for the top, you could start, and you can start with any letter you want. Like I could have started with G and said G, A, B, H. Just pick a letter, start it, and then go around the sides. And that's how you can name it. You need a minimum of 3. You could use 4. So that could be another way to name that same plane on top. Another name for the bottom plane, we could start, instead of starting with C, I could start with F, and I could go backwards, F, E, C, D, if you want to use 4. Now, this figure has more than just 2 parallel planes. It also has a pair and the planes on the sides. So I could say this side, along with this side, are also parallel. If you think about the classroom, the front wall there where the board is, and then the back wall, those would be parallel planes. So again, we can name this with a minimum of 3. So we could say the left side is plane AGF. And again, any order of those 3 letters, start wherever you want, parallel to the right side, and you could say EHB. Any combination of the 3. If you wanted to start with C, you could do CBH. And then one more pair, and this one's going to be kind of hard to see, but it's this front one right here. Let's see, I'll do it in black. From G to H to E to F, and then the back one. So it goes from A to D to C to B to A. So the front and the back of that one. So the front, you could start anywhere you want. So I could say G, F, E, and then the back plane, A, B, C. If you want to do A, B, C, D, again, you can name it with 4. So those are all the parallel planes in that figure. 2 postulates from chapter 3. Notice this time I didn't put numbers, because again, I don't want you to memorize the numbers. If you were to read your textbook, the textbook's going to tell you that the parallel postulate is postulate 3.1, and then the perpendicular is 3.2. Again, I don't want you to memorize those numbers. I want you to either memorize the name or what it says. So notice both postulates, they're basically saying exactly the same thing, but the only word they're changing is parallel and perpendicular. So the parallel postulate states, if there is a line, so let me draw the line, and a point not on the line, so I could put it right above it, then there is exactly one line through that point that is parallel to the given line. So for example, if I draw the line that's parallel, it's just going to go right through here. I can't draw more than one line that would be parallel. I could draw another line, but if I draw it this way, notice it's going to turn into intersecting lines. So there's only one line that you can draw through that point that's not on the line that would be parallel. Same thing for perpendicular. If I were to draw another line, connect it with 2 points, draw another point not on the line, there is exactly one line that I could draw that would be perpendicular to that other line. Again, I could draw another line through the point, but it would not form a right angle. And I could draw it anyway. There's only one line that you can draw straight up and down that would be perpendicular. So remember, the symbol for perpendicular, and we've seen it before, we saw it on the test, is the upside down T. So parallel are 2 straight lines. Perpendicular looks like the upside down T. Next, we're going to talk about a transversal. And a transversal is going to be a line that intersects 2 or more coplanar lines in different points. So the transversal in my picture here is line M. The 2 coplanar lines are the J and the K. Once that transversal intersects the 2 coplanar lines, it now creates 8 angles. These 8 angles are going to get special names. Before we start to discuss those special names, we need to identify which angles in this picture are the interior angles and which one are the exterior angles. So again, here are my 2 coplanar lines, J and K, and all of the points that are on the interior are inside or in between these 2 lines are going to be everything here in blue. So it's going to be angles 3, 4, 5, and 6. These are all the interior angles that are inside or in between those 2 coplanar lines. So those are the interior. Then the ones that are outside or exterior, like you're exiting, the exterior angles are going to be 1 and 2 and 7 and 8. These are exterior. They're outside of those 2 coplanar lines. Now, in the next section, what we're going to be doing is we're going to be straightening up these coplanar lines, and they're going to end up being parallel. Once we do that, we're going to learn some theorems and postulates that are going to tell us that these angle pairs that we're going to talk about next are either congruent or supplements, but that's coming tomorrow. Today, all we're doing is identifying the names. Part here is the inside, and the red part is the outside. So they're outside of those 2 lines. If you want to box it in so you can see it, these would be in the box and the other ones are out of the box. However you want to be able to identify. Now, also keep in mind that the transversal is not always going to be vertical. You could also have your picture where they draw the transversal. So let's say my 2 coplanar lines. Let's say this is J and this is K. And my transversal could come along this way. And again, they're not always going to call it M. It could be any letter. So again, this time my interior are this way. And my exterior would be here. And let me add in the 8 angles. So I could say 1, 2, 3, 4, 5, 6, 7, 8. Now, I just happen to put it the same way. 3, 4, 5, and 6 are not always going to be inside. It all depends on how you number your angles. Next, what we're going to do is look at the special angle pairs. So the first special angle pair is called alternate interior angles. And these alternate interior angles are two non-adjacent interior angles on opposite sides of the transversal. So they cannot be next to each other. They're non-adjacent. So I'm going to go ahead and color in my interior and my exterior. The other special angle pair here is called alternate exterior angles. And again, these are two exterior angles on opposite sides of the transversal. So again, I've got my interior angles here. Got my exterior here. And now to identify alternate interior, I'm looking for angles in the blue, but on opposite sides of the transversal. And they can't be next to each other. So for example, 3, its alternate interior cannot be 4 because 4 is next to it. So I would have to pick 6. 1 is on the left side, 1's on the right side. If your transversal is horizontal, you'd pick 1 from the top and 1 from the bottom. So angle 3 and angle 6 are a pair of alternate interior. I have one other pair. I also have 4 and 5. These are alternate interior angles. Alternate exterior, I'm going to pick 1 on the left side and match it with 1 on the right. Again, it cannot be adjacent, so I can't pick 2. So 1 and 8 are alternate exterior, and so are 2 and 7. Those are my alternate interior and alternate exterior pairs. I'm going to get 2 more special names, and then we're going to do some examples. The next special angle pair, they're called same side interior or consecutive interior. Our textbook calls them consecutive interior. The reason why I'm telling you same side interior is because some textbooks and some standardized tests, like SATs or PSATs, they call these angles same side interior. But our book will always refer to them as consecutive interior. These are 2 interior angles, but this time they're on the same side of the transversal. So we're just picking the 2 inside on the same side. So let me go ahead and highlight my interior, highlight my exterior. Actually, I only need the interior. Corresponding, I don't need to do in and out. I guess I could, but let's just leave it for this. So 2 interior angles on the same side. So I have a pair here between 3 and 5. They're on the same side, and they're both interior angles. So consecutive interior, consecutive numbers are like numbers in orders. So these are like 2 angles that are in order, like right next to each other. And then the other pair would be 4 and 5. I'm sorry, 4 and 6. These are the same side or consecutive interior angles. Next, we're going to talk about corresponding angles. And these are 2 angles that are in the same corresponding position relative to the 2 lines. Now, there's different ways that you can go ahead and memorize how to find them. I'm going to show you 3 different ways. So the first way, I'm going to use sort of what the definition is saying. And what I'm going to do is I'm going to draw a box around the 4 angles here. And then what I'm going to do is match the corresponding positions. So for example, if you think of the box, and I'm going to match all the angles that are in this top left section of the box. So you can see 5 and 1 are in that top left, so they would be corresponding. So 1 and 5 together, And then now the top right, that would be 2 and 6. And then we could say bottom left. So this spot right here, 3 and 7. And then lastly, the bottom corner, bottom right, 4 and 8. Those are your corresponding angles. So you can either choose to draw the box around and then match their spots, or what you can do is another way to describe this is they're all on the same side, the pairs are on the same side of the transversal, but to get to its corresponding, it has to jump over one. So you see how 1 jumps over 3 to get to 5, or you could say 2 jumps over 4 to get to its corresponding, which is 6. Another way to think of it is as one is inside, or an interior angle, and then one's an exterior. Again, we're not looking for adjacent, because we could have one inside, one outside, but they would be adjacent. We don't want the adjacent. So different ways to think about it. Either think about it in the same corresponding spot, or think about it's on the same side of the transversal, it jumps over one of the angles to get to its corresponding one. Now let's just do some examples. So it wants us to classify these as true or false. So it says a transversal intersects only parallel lines, and this answer is false. None of the examples I showed you had parallel lines. However, in section 2, we are going to make those lines parallel, but they do not need to be parallel. They just have to be 2 coplanar lines. Example 1b here, skew lines are not coplanar. Well, this one's true. It's the definition. The definition said 2 non-coplanar. So this one's true. 1c, if 2 lines are coplanar, then they're parallel. Well, they don't need to be, they could also be intersecting and still be coplanar. So I could draw a plane around here. So this one is false. Just because they're coplanar, they don't have to be parallel. They can be intersecting. Then the last one here, if 2 lines are parallel, then exactly 1 plane contains them. And this one's true. So if I draw a plane and draw my 2 lines, I could call them A and B. One thing you're going to learn also, or I'm going to show you, is when there's little arrows on the lines, these little arrows indicate that line A is parallel to B. These arrows aren't congruency marks. These are markings indicating that this line is parallel to the other one. If it doesn't have any markings, then it's not parallel. We're going to be using this a lot with our quadrilaterals. All right, example 2. So it says, think of each segment in the figure as part of a line. Which line or planes, depending on the question, appear to fit the description? So for part A, it wants us to find lines that are parallel to CD, but also include point A. So let me go ahead and outline line CD. So here is CD. And then here is point A. So I need to find a line that's parallel to CD, but it includes point A. So you can see that it's just going to go right through here, and it's going to be line AB. You could have also named this BA. So you either need to put the picture on top or write the word line in front. Now, let's say instead they didn't have containing point A. Another line that would be parallel to CD, just to practice, that doesn't include point A, Another parallel line could be EF, because that's parallel to the green one, and so is GH. So you could also say EF if it didn't specify that it had to have A. So these are also parallel, but what's missing is they don't go through point A. Let's try example 2B. It wants a line skew to CD. So let me get rid of this. I'm just going to leave the green. So skew to CD, but goes through point A. So skew to CD could be AH, and it could also be AG. So AH, you could also reverse it, say HA, also AG, or GA. The other skew line here would be BG. So a skew line that did not include A would be BG. Next, lines perpendicular to CD containing point A. So again, here's A. Notice the little right angle there. So I could show that line AD or DA is perpendicular to CD. You can see the little right angle. So AD, or you could call it DA. That would be a line that is perpendicular that contains point A. Now, other ones that do not include point A that are also still perpendicular, so we could go up this way. We could say ED. We could also go up this way, CF. And then this one along the back, BC. These would all be perpendicular. The only difference is they do not go through point A. The only ones that would answer the question would be the red ones. And then the last one, a plane ABCD, let's see, a plane parallel to EFG. So let me go ahead and erase this now. I don't need any of that. So let me outline EFG. So EFG is here. And the plane that would be parallel to that would be the top. And any combination of those four letters. If you want to use all four, A, B, C, D, you don't necessarily have to start at A. You could have gone D, C, B, or D, A, B, any of the at least three from the top. If you want to list all four, you can. And then one last example. Pretty good here? All right. Wants us to name the given angles. So alternate interior. So if it helps you to highlight the inside part, you can. You don't have to. And then your exterior part, or your outside. So the alternate interior, opposite sides of that transversal, but in the blue area. So we could say 2 and 7, opposite sides of the transversal. And then the other pair is going to be 3 and 6. Consecutive interior. I'll go ahead and erase what I have there. So consecutive, remember that's also called same side interior, or right in order of each other. So 2 and 3. So they're right next to each other, but they don't share a side. And they're both inside. So 2 and 3. And then here also 6 and 7. Corresponding, you can either choose to draw the box or just know that it skips over one. So this one, there's actually 4 of them. So if I draw my box, so in the upper left, you have 1 and 3. In the bottom left, 5 and 7. And in the top right, 2 and 4. And then in the bottom right, 6 and 8. And again, also think about it as it jumps over it. So for 1 to get to its corresponding, it has to leap over 2. For 2 to get to its corresponding, it jumps over 3 to go to the 4. So it like skips one. And then lastly, the alternate exterior, so that's in the red. Opposite sides, so you can have 1 and 8 and 5 and 4. The order that you write these, it doesn't matter. If you were to have written 8 and 1, you can switch the order. You're just listing them. And that is it for 3.1. Now, what I want to show you is how we're doing the homework now. So I'm going to show you the rubric first, just so you know that your homework is now based on accuracy.